Hello there, my dear virtual little siblings. Today I'm joined by Minsue from testqube. And in total, the testqube team has written over 4,000 practice problems for the digital SAT. In today's video, we're gonna discuss 1, whether the DSAT is actually getting harder, and 2, share some tips to help you nab that perfect 800, specifically on the math section.
Thank you, Kevin, for that lovely intro. And hi guys, once again, my name is Minsue and I'm from the testqube math team. To answer the first question given by Kevin, whether is the DSAT math actually getting harder? The simple answer, and in my honest opinion, is no. And to be more exact, the content itself didn't become more difficult, it's just that it feels more difficult because it requires a slightly different approach towards the questions. Now, what does this mean? And are there any tips to achieve the perfect scores? Let me show you. Tip 1, new variations, same concepts. Imagine this, you're practicing a topic, let's say histograms. You practice solving classic questions like estimating the mean, or calculating the things like median or mode. Or you maybe even do a couple of questions about comparing the data between the two different histograms that have been given. And then you take the recent digital SAT math test, only to find out that the way it's asked is totally different. For example, check out this gnarly question from a recent Blue Book practice test, where it asks for the smallest possible difference of means between the two given histograms. Now, it's totally normal to panic when faced with something unfamiliar, but you gotta remember that the digital SAT math never tests concepts beyond the given curriculum. Now, at first, this question might seem really confusing. It seems like that they want you to calculate all the possible mean averages from both histograms. But actually, this question is much simpler than you think. Let me show you. Now, we have to figure out which dataset would have to find the least possible mean and which dataset would have the largest possible mean. Now, if you look at the bars closely, we realize that the frequency of the bars for both histograms are actually the same height. So, got frequency of 3 here, 4 here, 7 here, and 9 here, which is the same also for dataset B. From here, we realize that when the frequency of the bars are the same for both datasets, the way we figure out whether which one would have a larger mean average is by simply looking at where the bars are located. So if you look at dataset A, we see that the bars are shifted more towards the right-hand side, meaning it would have the data that has a larger value. So we know that because dataset A would have a larger mean average, we know that it's the dataset A that would have the least possible mean, and dataset B that would have a largest possible mean. Okay? Now, normally when you find a mean average, you would try to find every single data and then you add them up all together and then divide by the total number of data to find the mean average. But in this case, because the heights are the same, this is actually going to make the question much more easier. So you take a look at dataset A first. We see that for the first bar, between the data value of 20 to 30, now because we want to make dataset A the least possible mean, we have to pick the least possible data from this category, which would be 20. And if you apply this for the next bars too, the least possible value for the next bar would be 30, 40, and then 50. We go to dataset B now, where the first bar would have a possible values between 10 to 20. Now, because here we want the maximum possible value to find the largest possible mean, the data with the maximum possible value or the first bar would be 19, 29, 39, and 49. Now, we've mentioned before that the heights of the bars are the same for both datasets. So, because the heights are the same, that means they have the same number of data altogether. What matters more here is the difference of the data. we see that all the data in dataset A is 1 larger than the respective bar with the same height from dataset B. So every single data from dataset A here would have the value of 1 higher than the dataset B. Same also goes with the second bar, where all the data from dataset A, which is 30, is going to be 1 higher than the highest possible value from the second bar in dataset B, which is 29. And this also applies to a third, where it's 40 minus 39, and this also applies for the last bar, which is 50 minus 40. So all the value in this scenario, where we're trying to find the least possible difference between the mean average, all values would have a difference of 1. So if all the values have a difference of 1 between dataset A and dataset B, that means the mean average of dataset A and dataset B is also going to have a difference of 1 in order to have the least possible difference between the two datasets. So naturally, the answer of this question would be B, 1 here. You see, all we need to know is the principle of how to find the mean averages, but we don't actually have to calculate the mean averages for the different scenarios. We just need to know that to get the least possible mean from dataset A, we just have to use the smallest possible number of the bars here. And to find the largest possible mean of dataset B, we just have to pick the largest possible value of the respective bars to approach this question. Tip 2, more variables in questions. Now we've noticed that recent questions in the DSAT math are incorporating multiple variables, making even short questions appear more complex. Now usually in early DSAT math questions, you would tend to see at most 3 variables in the questions. But this Blue Book question from the more recent practice test contains 4 variables, and this question is much more shorter in length. Now, to tackle these kinds of problems, keep these 2 strategies in mind. 1, interpret the sentence carefully and translate it into equations or expressions to simplify the question. 2, identify the most important variable. Now, how would you do this? Usually, in majority of the cases, the most important variables, aka the answer that the question is trying to ask for, is given at the end of the sentence. So make sure you link that asked variable with the equations or expressions that you have previously interpreted before. We take this question as an example. We're going to go each sentence step by step. So first sentence says a positive number A is 230% of B. Is, now we know that is means the same as equals, and of is the same meaning as times. And all we have to do is to convert 230% as a number, because percentage talks about the rate. And if you know about percentage, we know that 230% is the same value as 2.3. So here we can simplify this first sentence as A equals 2.3B. Now, the second sentence, it says A is 60% of C. If we translate this like how we did before, we're going to get A equals 0.6 C. And the third sentence, it says C is P% of B. If we were to convert this, we would get C equals P over 100 times B. So from that question alone, we are able to translate the sentences into 3 different equations. Now, what is the most important variable in this question? Now, it says in the last question here that which of the following is the closest to the value of P, meaning that our main goal here is to find the value of P itself. So from the previous equations we've written before, we've said that C equals P over 100 times B. which means to find this value of P, we gotta use the equations that we've written before to have in the same format as this so that we can find a P easily. Now, we previously mentioned that A is equal to 2.3B and A is equal to 0.6C. So based on these two equations, we want to form the equation that looks similar to what we've had in the beginning. So we see that we want to have C on one side and B on the other. And because for these two equations, the A values are the same, we can basically structure our equation as 0.6C equals 2.3B. Because like I said before, both of these have the same value as A. So now we have to form it so that our left-hand side only has C remaining. So to do that, we divide this 2.3b by 0.6. 2.3 divided by 0.6b. We see here that our newly written equation here has the same structure as what the question is asking before. All we have to do is to find out the value of P. So 2.3 divided by 0.6 equals to P over 100, which means P would be equal to 2.3 divided by 0.6 multiplied by 100. And if you use a calculator, you would get an approximate of 383, which, as you can see, corresponds to answer D here, which would make this guy as the answer. So you see that although this question has 4 variables and it might make it look confusing, we were able to shorten it down as a couple of equations and using that key variable P as our main guide to make sure we structure and rearrange the equations so that we're able to identify the value of P easily. So we take this question as an example. The question says that the quadratic function g models the depth in meters below the surface of the water of a seal t minutes after the seal entered the water during a dive. So we know that g is a quadratic equation that is impacted by the independent variable of t. So we know that our quadratic function is going to look something like this. It's slightly hard to differentiate t and plus, but that's the best I could do. Now, if we read the end of the question, it says, what was the estimated depth to the nearest meter of the seal 10 minutes? Now, what this question is basically asking you to do is to find what is the function of the quadratic function g and t, and to just calculate what the depth would be when t is equal to 10. So it's simple. This question, although it looks super long, it's asking you to A, identify what the quadratic function is, and B, just plug in the value 10. So what is the quadratic function g of t in this case? We read the additional information that they've given us. We see that the function estimates that the seal reached its maximum depth of 302.4 meters 6 minutes after it entered the water. From here, they've given us the maximum point of the function, which means that our quadratic function can be written as a maximum point format, which is a x minus h squared plus k. And this is when k is the maximum point. We also have to note here that because the question gave us the maximum depth here, we know that a has to be a negative value, because for a quadratic function to have a maximum point, it must be this concave, it must be in this form of shape where the leading coefficient of the quadratic function, a, has to be less than 0 for the maximum to exist. Okay, so with that in mind, the other information they gave us is that the seal then reached the surface of the water 12 minutes after it entered the water, which means that when the time is 12 minutes, the seal reached the surface, meaning that the depth itself would be 0. So, based on this given information, what can we fill in the gaps? Now, they already gave us the maximum point of 6. After 6 minutes, it's going to be 302.4 meters. So we can just plug in the value 6 into h and 302.4 into k. Now, we have to find the value of a. How would you do that? We use the second clue they've given us, where g of 12 equals to 0. So g of 12 equals a 12 minus 6 squared plus 302.4 would equal to 0. Now, once you get this equation written down, you would have to solve for a, which if you use a calculator, you would find out that a would equal to negative 8.4. So, after figuring out the a value, we can now conclude that g of t is equal to negative 8.4 x minus 6 squared plus 302.4. Now, going back to the beginning, what did the question ask us to find? The estimated depth of the seal 10 minutes after it entered the water. So, we have to find the depth when t is equal to 10. Sorry, it has to be t here. We will just plug in t, 10 into the t that's been given. So it's negative 8.4, 10 minus 6 squared plus 302.4, which would give you, if you use a calculator, you'll find out that the depth is equal to 168 meters after 10 minutes. Therefore, your final answer in this question would be 168. So, as you can see, although this question might look extremely long and overwhelming, all it's just asking you is, as long as you know how to express a quadratic function and how to substitute the numbers based on the given clues, you would be able to tackle this question extremely easily.
Hey everyone, I'm Benjamin Yu, CEO of testqube. Today we're giving away nearly $50,000 in free test prep to students in schools who need it most.
Teachers, administrators, students, if your school could use these, email us. This is our way of giving back and making high-quality test prep available to all. The first 555 people who comment below will get free access to the testqube Pink Book, which includes 4 full practice tests, video explanations, and access to live DSAT question review sessions. Our mission is to make high-quality test prep and educational resources available to all. Thanks for watching.